Let's take a look at the idea of how to anti-differentiate, or you could say how to integrate if you like. And what we start off with an equation that's already been differentiated. So I might have f dash of x, or f prime x if you like. Let's say it's equal to 2x cubed minus x squared plus 5. Now right now that is the differential equation, or if you like, it's the gradient function. Now we want to find what the original equation is. Now we actually don't have enough information to know what the original equation is, but right now we've got enough to come up with a rough idea of what the equation was. And to do that, all we do is write f of x equals, we're going to rewrite this, and each x value I'm going to increase the power by 1. So here's x to the 3. I'm going to increase that by 1. 3 plus 1 is 4. So I write a 4 there. And I'm going to divide by the new power. Here I've got an x squared, an x to the 2. I'm going to add 1 to that power, making it a 3, and divide by the new power. Here this is technically an x to the 0. Of course, we don't write x to the 0, but that's really what it is. So we're going to make this one more power of x. It's not x to the 0, it's now x to the 1, and we're going to divide by the new power. Now, there may be something else there which we haven't seen, and we put what we call the constant of integration. So put plus c, that's our constant value, and later on you'll see how that plays out. So let's tidy this up. So now f of x then is equal to, well, 2 on 4, that's a half. So I could write a half x to the 4 minus, this is going to be x on 3, I like that, plus 5x plus c. Or I could have written here half x to the 4, this could be 1/3, negative 1/3 x cubed. Or I could have written here, I could have just said x on 2. I like x on 2 better. It's a little bit more succinct. This one's got an extra component. It's got that 1 there. I don't really like the 1. I'm just going to call it x on 2. I'm going to call this x cubed on 3. And I'm going to call this 5x plus c. Now let's imagine, just for argument's sake, that we were actually told a certain part of this. So we've got f of x, and we were told that, let's imagine, when x is 0, so in other words, if when x is 0, f of x is equal to 3. Well, what that means is, so this now is 3, and I'm going to replace 0 for all the x values. So it's going to be 0 to the power of 4 on 2, minus, this is going to be 0 to the power of 3 on 3, I'll put brackets around that, plus 5 times 0 plus c. So 3 is equal to, well, this becomes 0, this is 0, this is 0, and we've got a c left, so c is equal to 3. So now we can rewrite the entire equation, which is x to the 4 on 2 minus x cubed on 3, plus 5x plus, now we know that c is 3, and I can just substitute that in there, 3. And there is our equation. So in other words, all we do when we anti-differentiate is we rewrite the original equation, we increase each x power by 1, and divide by the new power. That's a 4, this becomes a 4. 3 becomes a 3. 1 becomes a 1, yeah? And now, if that's all we've got, then that would be the best we could do. That would be the equation. But we've got this constant now. If we knew one point, like we knew that if x was 0, y would be, or f of x would be 3, or another certain number, then we could substitute this value in for all of the x's and make c the subject. And by doing that, we would be able to find the actual equation in its entirety.